Yo, what's up? This is, I think, the last day of February LeetCode challenge. It's maximum frequency stack. So basically, you have to implement a stack, but there's a slight difference in the operations. A normal stack with just push and pop. In this, push will automatically, it will implement the same thing. You push a value, push the value into the stack. But for pop, you need to either you need to remove the most frequent element in the stack, or if in the case that more two elements have the same frequency, you need to remove the element which is closest to the top of the stack. Okay, so in order to make use of this, we're going to in order to do the pop-up. See, normal push operations we can just put into the stack and do it, but since it's a frequency stack, the one thing which is for sure from the question at least you can get is we have to use maps, because to keep the count of the frequency. So while popping is where there's the tricky part. Okay, so in that case we need to use a vector of stacks so that you can figure out which one is closest to the stack. So I'll show you how it is done. So let's take this operation, okay, and then we'll paste this into this thing. Yes. Okay, it did not come the best way. You're just a noob in open board, okay, when you're doing this. Hope you're good at it that time. Yeah, it doesn't matter. So basically, we generally what we do is with in a stack, what we do is we just sorry, my bad, bro, my bad. You can just fast forward half this shit. So in a open stack, in generally in a stack we'll just put 5 7 5 7 then 5 4, like that will keep going, right? So but whereas in this, since we need to keep count on the frequency, we'll create an index, we'll create a vector of stacks in which the index will hold the obviously the this thing we'll create a vector of stacks in which the index will hold the value of the frequency, that is the frequency minus 1 will be the index of the stack. So in that case what we do is if so basically, where is the freaking pen? So we create a vector of stacks, so in which this will be 0 1 2 3 4, okay, and then so I can just put this as 0 1 2 3, okay. I think the max is 2, so it's not an issue in this. So in this first case, the vector will be empty, obviously. So you notice push, okay, push will be equal to push is 5, so 5 will be pushed into the stack. Just a second, is it recording? Yeah, it's okay, fine. 5, and then next value is 7. 7 occurs for the first time, so the count, yeah, side by side, the this thing, the count of 5 will be incremented in maps, so that you know how to do it. So then 5 will be pushed over here, then 7 will be pushed over here. 5's value is again repeated over here, so 5 frequency will become equal to 2 at this point. So 2 minus 1 will be 1, so 5 will be pushed over here, and then 7 has the same thing, so the frequency of 7 will be equal to 2. 2 minus 1 will get pushed into the stack. Like, you get what I'm trying to say, no? So the frequency minus 1 will be this, will be where you push the values into the stack. You'll understand why I'm doing this when it comes to popping. So I'll just do it for 4. 4 is coming for the first time, so 4 will come over here, and then 5 will come over here, so it will come over here. So since it's third time, 3 minus 1 is equal to 2. So now popping starts. So the last element, which is with the highest frequency by default, is 2, because 2 is the so since it's going in the index, you get it. So the frequency with the highest will be 2. So the 5 will be popped out of the stack, and then 5 count will be reduced by 1 in the map, okay. So then now next will be popping out the next element of the stack. So next highest frequency obviously will be between 5 and 7. So you can see 2 5s, 2 7s. So but since it's in the form which is closest to the top of the stack is 7, right? So 7 will get popped out of the stack again in the same way. Next will be 5. So this third pop, right? How many pops are there? I think there's one pop which is missing. So here again one pop will happen, which will indicate 5 is again removed from the stack, and then finally another pop. There is supposed to be, I think, 4 pops, but here it came as 3 pops by mistake, so it'll be 4 pops. So first will be 5, since it's the closest to the top of the stack and the most frequency which is indicated by the index, and then the next highest frequency will be 2, right? So in that case the closest to the top of the stack will be 7, after which is followed by 5, and then after which it is followed by 4. So in general what we do is we take a map which keeps in count of each key the count, and the stack which hold a vector of stack, so that you can figure out the one which is closest to the stack. At the same time, see, the maps count is used for as an index for pushing elements into the stack, and while popping out the elements, what we need to know the one which is closest to the stack. That's when we make use of this vector of stacks. You can use a list of stacks, but when you tried that out, it was pretty tricky, so we use this. Okay, so I guess you understood it. You'll, if you not, just understand it through code, I guess. Code. So we'll just go to the code. Where is the code? Yes. Now yeah, so here what we do is, first we need to declare two things. One is a vector of stacks, so that is stack of int, which will be like stack list, you can say. Other one will be a normal map. Okay, so map int comma int, and then you can just say frequency count. Just put frequency, that should be enough. So then at this point you have nothing to declare over here. So here basic normal stuff, frequency of the particular value, plus plus. So now you need to push the value into the stack. By default, if you see here, the stack list is empty, so that's when you have to check if so the count will be increased. Okay, int value will be, or int count of frequency val count, okay, sorry, too many variable changes, is equal to frequency of x minus 1, because we're just going to use this as the index value for checking if the list exists. So let's assume for the first value the stack is empty. Okay, so then if you check if var is greater than or equal to 0, a greater than or equal to stack list dot size, so both are empty. First it's checking if 0, the first value which needs to be pushed is 5 value gets incremented to 1, so 5 minus 1 0. You check if the size of the stack is 0, greater than 0, which is true. So that means you need to create a new you need to push a new element. How you put it's basically like, how do you check if this value if this element is already there or not? If it's not there, if it's a new element to be added, we add a new element to the stack. First we need to increase the size of the stack, right? So the same thing, we're going to do the same thing over here. I'll just show you for few more examples. I think that will be better. So it's just a one liner, so that's why I removed this thing. Stack list push underscore back, and then stack of integer empty. This will just push an empty stack into the list, thereby increasing the size of the list. That vector will take care of it. You know about that. So this is a new thing. Okay, pushing an empty stack. This is how you push empty stacks into a vector of stacks. I didn't know that. So then after that, you have to push the element into the stack, right? So that will be stack list of val underscore count, which is supposed to be over here. I made a mistake. Val underscore count. Yeah, val underscore count dot push will be equal to the x value. So what this basically does is, where is it? Show desktop. So here what this basically will do is, initially the vector list will be empty, right? Where's the pen? Yeah, vector list will be empty. So I'll check if the index value is there. It's not there. So at this point, I'll create a new free of index 0. It'll create a new stack of having with having 5 over here. So then next will be 7, right? If you see on top, it's 7. Okay, next element is 7. So of that index, then again I'll check frequency of 7 will be increased to 1. Frequency of 7 equal to 1 minus 1, which will be 0. Val of 0 is equal to greater than or equal to stack size. Stack size will be 1, so this will be false. So stack of 0 dot push of 7 will get pushed. So next will be 5. Okay, 5 will count will be increased to 2 over here. 2 minus 1 will be equal to 0. So unless you want, I'll make a map. 5's count will be increased to 2 over here. 7's count will be equal to 1. Okay. So then once 7's count is 5's count is incremented to 2 minus 1. So one is greater than or equal to stack size. Stack size is, we are making use of the val count as an index, but if it's greater than or equal to stack size, that means this is a new element which is needed to be added. You know this, but I'm just saying. So in this case, for stack for index 1, a new element has to be pushed in. A new element indirectly pushed means a new empty stack will be pushed over here. So after which, for the stack list of index 1, right, that will be 5 will be pushed over here, because the first element it encounters is 5. After which again I think 7 gets 7 is the next element to be called. So stack of size 2 will already be there. So value count is 1 greater than or equal to size 2, which is false. So stack of 1 stack list of 1 will push 7. I hope you're getting it. Like, if you read the code, you'll be able to understand. At least that's what you were able to do when you saw the question once. Next element was 4. Okay, 4's count will be 1, so index value will be equal to 4. So the index value will be equal to 0. 0 is less than or greater than or equal to 2, which is false. So then stack of 0 will push the new element 4. Okay, so then like this will go on, and then in that case you're just going to incrementing the list only when it encounters a new values or having a frequency which is greater than or equal to the size of stack, because we can't use that as the index. So I'll just show you the listing, the popping part. So that's I'll just draw rest of the elements in this, so that it'll be like easier for you to understand. So I think this one again will be 5. Yeah, that's it. Yeah, so it'll be 0, 1 and 2. Okay, now we'll do the popping part. So obviously what we need is, we need to pop out 5. Okay, over here. So how will you get it? The stack size is equal to 3. So index value will be equal to stack list dot size minus 1. Okay, then we can just reduce value, what is that, frequency of id. Okay, no, we need stack size distinct. So stack size of top value, yeah, so that will be int value will be equal to stack list of idx dot top. That will give you the value of that will give you this value. Okay, that will give you the last entered value, true. So then after which you reduce the frequency count of val. Okay, frequency count of val minus, and then you need to pop out this thing. You need to pop out the value, because you're going to remove this. You need to pop out stack list of idx dot pop. Yeah, so that will remove this element. Okay, after this index should remove this element. So if that's the case, we need to reduce the size of this thing, right? We need to remove the stack, so that means the stack is empty, which we don't require this element in. So we pop out the last element of the vector of stacks. So what we do is, we'll check if stack list of idx dot empty equal to true. If it's true only this will run, right? So then stack list dot pop underscore back. Okay, and then return val already stored. So basically what this does is, it will return the last element. This will give you the index of the size of the last element, because the last element will be the value which you pushed into the stack. Okay, and that will be obviously with the highest frequency, because it goes in incrementing order. So this basically takes care of two things at a time. One is the one with the highest frequency, and the one which is closest to the stack. So if you see in this case, so let's start with 5. Okay, 5 will be as a frequency 3. So in order to get 5, we use stack of idx dot top, which will give me val. So that will reduce the value by -1 by reduce 1. So this will get from 3 will become 2. I didn't change the value at the end. So this will become 3 to 2, and there will be 4 also here. So that's another thing. So then at this point of time, you'll pop out the element. So then once you pop out the element, you check if the list is empty, if the stack is empty. If this stack is empty, you can pop out this, so that this idx thing won't have an issue again. Others will keep printing. It'll give me an underflow value, which you encountered when you tried first time. So then after which you can pop out the last element of the stack, that is pop out the empty stack. So that will be stack list dot pop underscore back. So this will remove this element itself. So this will basically go away. So now the current size of the stack will basically be equal to 2. So then idx will be equal to stack list of size this thing, so that the idx will be equal to 1. Idx will be equal to 1. So value of 7 will be the idx will be 1. So frequency of val will give stack list of idx dot top will give me 7. Okay, so frequency of 7 minus, so then you'll get the next highest frequency element. See, in this case both of them are the same this thing. Okay, it should be 2. So we need to find the closest element. Since we are using a stack implementation, the one which will be closest to the stack will be 7. So this will get removed, and then after which this will get removed, then this will get removed. Like that will keep going on. I hope you got the idea. I try not to mess up. So yeah, I think that's how it works. As if I didn't make any stupid error in between, then this should run. Yeah, so it worked over here. I can just press submit. Yeah, so basically what we try to do is we use two things as I told over here. One is for keeping the frequency count, which will be used as a index, the map thing. Another one is for a list of vector list. Okay, you were able to figure out this. You were able to figure out maps. You were not able to figure out stack list. Okay, so just look into that. Apart from that, you're good to go, bro. And with this, you end February's challenge. This is the first time you did a complete monthly challenge. It's kind of epic. So see you, boys.